Okay, let's give you guys some more practice. So will this integral converge or will it diverge? Remember, from 1 to infinity, from 1 all the way to infinity. So will it converge or will it diverge? So press pause and have a go. Okay, so the trick to doing this is to realize that, well, for x being greater or equal to 1, if you look at this, x squared will always be bigger than this thing here, and then x squared will always be bigger than this thing here. So the point here is that this thing here, let's have a look at this thing here, this thing here. Well, that if you look at this here, x squared will always be bigger than x for x being bigger or equal to 1. If you look at the graph, y equals x, it will look like this. X squared will look something like this. So this here is 1. For x being bigger or equal to 1, so all the way here, you can see that x squared here is bigger than, you can see that x squared would be bigger than this. Now if you compare this with this, y equals 1 will look like this, x squared will look something like this. Now for x being bigger or equal to 1, so all the way across here, you can see that x squared is always bigger than this thing here. So we can say that this thing here will always be bigger or equal to this thing here. So the point here is that this thing here will definitely be bigger or equal to this thing here. So we can say that this is bigger or equal to this thing here. So now exactly the same, add them all together, that would then give you 3x squared. So that would then take us to here. So now if you look at this here, if you look at the denominator, if you make the denominator smaller, then the overall thing will be bigger. Now remember, if you make the denominator smaller, then the overall thing will be bigger. So if you get rid of this 3, the denominator will be smaller. So we can say that this thing here will be bigger or equal to this thing here. Okay, so now we can say this thing is bigger or equal to this thing here, because we've just made the denominator smaller by throwing away this 3. So therefore this thing here must be bigger or equal to this thing. And then now use the same argument. Look at the denominator. If you're throwing away this bit here, then you're making the denominator smaller. Don't forget, you're not throwing away a negative here, because we are dealing with x being bigger or equal to 1. So this is not going to be a negative. Well, we are dealing with x being bigger or equal to 1, so it's not going to be a negative. So the point here is that if we can make the denominator smaller, let's throw away this, then we can definitely say that this thing would be bigger or equal to this thing here. So now simplify this. So divide top and bottom by x squared. That will then give us this. So now we can compare this complicated thing here with this thing here, with the integral dx from 1 to infinity. Well, this thing here is a constant, so let's take it out. So now we can look at this now. Now you're supposed to ingrain this in your mind. Whenever you see this from 1 to infinity, 1 over x squared is going to converge. This thing here is going to converge. So this thing here is going to come to a definite number. And then when you have a definite number, let's say 37, you times 3 is going to be another definite number. So if this thing here converge, when you times 3, it will converge. Well, if this thing here, if this thing here is bigger than this and this converge, then this will have no choice but to also converge, because this is smaller than this thing here. It's smaller. So if this thing here converge, then this being smaller than this, then this must converge. Okay. So if you get a graph plotter and plot this, hang on. If you get a graph plotter and plot this and this, you can see that this is always bigger or equal to this. Okay.